And hello, everybody. I'm Albir, and today we'll go over trust issues on quite a different perspective. So, from the user authentication perspective, right? And it's going to be a practical guideline basically for multi-tenancy and authentication. So when we say authentication, that's probably the most important thing of the app, right? Because every app needs to have some sort of authentication, but it's also the biggest part of programming that causes the biggest downtimes and the biggest production issues in history in general. So let's say before we define anything, I actually want you to quickly answer to yourself. Just think about it. When your API gets a request, what in that request do you actually trust? The browser, the front end, the API layer, the database, the user's JWT token. Pick one and defend it. Most bugs and parts of these trust issues with authentication and authorization we'll cover today are basically defined by it. So, let's say we trust the user, and let's say we want to do something which will fix today's biggest problem, which is actually every app starts simple. The user logs in, a dashboard, done. But production systems actually do not stay that simple behind the scenes. Walk through the chain. Basically, if you take into consideration how much it takes to resolve a simple session, it could belong to an organization would grant the role, and so on. That would be multi-tenancy. So the identity of the user is basically tied to the session, which is defined by the organization. And why do we do this? Basically to have some sort of pseudo mode onto the user before he actually starts making any permissions. That's basically what you can see in today's most viable production systems, where you have basically just scopes. And those scopes grant you specific permissions. They don't actually grant you the entire website. And that's how we basically need to structure an authorization system in 2026 if you don't want it to go the other way around. So no, if you want to avoid any issues and any production bugs. So this is the basically spine of everything that we'll cover today. Authentication answers who you are. So, and authorizations answers what you're allowed to do. So, multi-tenancy answers those stuff you're allowed to touch. So basically think of it as a real world scenario where you basically just say who you are, like me, like I'm Admir, and what I can do at this point of time is have this live stream with you guys. So that's basic, most simple definition between how to distinguish authentication from authorization. So you basically just ask these two questions. Every failure we'll discuss today is one of these three questions. So it's really important to have multi-tenancy, because in that case, you answer the questions, whose data can you touch? So is it really important that you touch everybody's data on the platform? once you make it. Okay, so let's start with who are you? So authentication is basically identity verification, proving you're who you are. So basically, it will be as me proving today that I'm Admir in front of you guys. And basically, it goes over credentials, which is your password and your username, maybe your email address, personal information, and it can go to sessions, tokens, Auth, and OIDC for, let's say, bigger projects, and if you're doing something enterprise or no passwordless flows. Yeah, architectural-wise, authentication is just a sole problem that you build. It's the part you have to design the most commonly the biggest one, because based on that you will find out how your backend project is going to look in a few months, right? I would argue that it's the best possible way to have it distinguished into authorization, and multi-tenancy in general. So if you're authenticated, that doesn't actually mean that you're authorized. So let's say I log in successfully, authentication passes, and I request an API route. Let's say get user 42. The question the authentication cannot answer is if I'm allowed to see that person's details through the API. So it's a completely separate decision on the architectural part. If you're gonna go into details, you can argue that in the most part, you'll have authentication and authorization separately, but tied together via the entire code base. Why? Because as previously told on the example, I can have a valid session cookie, I can have logged in into the project, but does that mean that I should actually be able to see and edit, eventually delete every part of the application? Being logged in, so authentication in general, answers just one question, and that is, it answers it really well, and that is just, I'm just logged in. I only have a session. I don't know who or what I can touch yet. So that's the biggest part of the general sessions which you have to take into consideration. Yeah, sessions. So let's go over those. Just a sec. Yeah, the most commonly used authentication method in today's programming is via sessions. And what are sessions? Basically, they hold states, and they can only hold a cookie ID. For example, just take as an example, if I had a cookie, it would only have my identification token, and it would only cover the levels that actually matter, which are expiration, rotation, and privilege change. Eventually revocation on logout, and HTTP security and same site stuff. Okay. JVTs aren't actually magic. If you take into scope like how a JVT token actually looks like, it's just a set, a JSON payload, which holds up your basically the only base information you need on authorization. So it's useful across services for stateless APIs. It can cover claims, refresh tokens, validations, and the server which you make it on. So your backend, which you will make on this backend rack, has to actually be the one that signs it and the issuer. So that there's a simple claim that oh, JVTs are tied into your authorization flow of your actual backend. So your actual server where your backend is deployed needs to be the sole owner and signer of your JVTs. In case it isn't, it won't even be recognized by itself. So the biggest must is to verify the signature, issuer, and audience on every request. And that happens because, let's say, if I made a user on one dashboard, if I try to log into a completely separate dashboard on the internet with the same user, without this verification, it wouldn't be possible. So a JVT is only trustworthy as is the validation you perform. So if you don't perform any validations on your JVT, it's basically useless, and you should take into consideration that putting a claim inside the token doesn't actually make it true. It means just that someone signed it at some point and an expiration rate has been set. So validating the signature and the expiry and the issue and the audience every single time should be handled by your backend and yours only. So that's the one thing you can keep in mind that you wanna have on your end. So the browser actually, like, let's take into consideration, let's take as an example Google Chrome isn't really trusted. You know, the HTTP up above near the toolbox, that's actually quite a bit just from the networking side. It doesn't actually trust from your server. So anything can live and can be added by client, hidden fields, local storage, state, URL params, custom headers, a disable button. Every one of these is a suggestion and not a fact. So if you want to gate it in the way intended to, you should look into having your server validate everything instead of the browser. So never trust anything from your front end because it can be easily exploited. And if you ever heard of XSS scripting or injections, that's basically when you open up the console on the browser and you have something on the front end exposed. Everything you have on the front end as a variable, as a state, is exposed to the end user on the actual console. So you have to be really careful that the entire authentication flow, besides the actual request going to backend, is fully on the backend side. So now we get interesting. Authorization is basically just identity. Now, the fun part here is deciding what identity can actually do. This is where I've seen the most security bugs in production happen and currently live because it's where teams stop to kind of be rigorous. Authorization is a design problem and not actually a library you install. So think of it as you have to beforehand design the scopes, design the permissions, go over everything you think your users need to go through to be able to actually handle it. So the authorization question. The biggest question in authorization in general is every protected action conceptually answers four things. Who is acting, what action, on what basis, and under which context. So, in this example, Alice does delete on project ID 123 inside the Acme organization. So we basically here have scopes, and if she has the right scopes and permissions, she will be able to do this. If not, the request should just drop. And besides this simple authorization part, you might also come across role-based access control. So let's say you have a bigger backend. Let's say you're doing a news portal and you need many different people working on the same dashboard with different roles and permissions. This is where role-based access control, as a simple term, really comes into the light. So the biggest benefit of it is it's simple to reason about. So we have an owner, an admin, an editor, or sometimes moderator, and you have a viewer. And this goes into, let's say, a simple individual grant scope. So it's really easy to explain to customers and anybody on board to your project that an admin is an admin and a viewer is just basically a viewer. And it can get quite messy if not done right. So this is what actually happens 6 months into a real product. Admin but not billing, admin except production, admin only in the European Union, and each exception became a new role. So let's say as you go, you understand what scopes you actually need and actually define the biggest like role-based access control for projects. This is a role explosion. So the tell actually is that you need explicit permissions, not more roles. So in case you want to structure admin differently, so you want to segregate it into different parts, it's better to not make 6 different admin roles, but just one big admin role with different scopes. That's how actually you'll get a lot better, and your system isn't going to look really messy down the road once you have like 20 admins, 20 users, 20 moderators, 20 types of everything. Permissions. The fix for all this entangled stuff is basically permissions. You should always name them explicitly instead of inventing a role exception. Resource action pairs like project read, billing manage, members invite, roles that became bundles of permissions, not the actual source of truth. And a good example is just billing manage, billing read, billing view, anything that can just go over quite easily and transition into different roles quite easily. So roles as a general are a bundle and the permissions are the primitive. So think of roles as a group in a box and it's filled with permissions, right? And that box is only able to be used on a single user with those roles. So it kind of goes hierarchically into the role, permissions, policies, and decisions. It's not the ultimate security perimeter, but the permission policy decision chain is what actually gets evaluated at request time. So if you take a look deep down under the hood, how your backend is going to interpret this request is going to go literally into the daisy chain of decision, policy, permission, role on that user. So it gets quite granular and easy to understand once done right. So one thing people actually quite often, and I see that mess up, is that the ID is not a permission. So this is an example of IDOR, insecure direct object reference, sometimes called BOLA, or broken object level authorization, which means that if the only check is if there is a logged in user, any authenticated user can enumerate every invoice ID and read someone else's data. And you would be fascinated at how much this actually happens in production, because if you take a look from a further side, it's mostly like, okay, I have this API route. I see that the user is logged in. Okay, let's just tie them to the ID. This is where role-based access control comes in really handy, because it will cost you, it will take away the pain of you having to think which authenticated user actually messed up data which they weren't supposed to do. So, bad authorization. There are a lot of examples of bad authorization you can find, and this is the code most of us have shipped into production at some point, including myself. It fetches the invoice ID by ID and returns it. There is no ownership check anywhere in this function. So if you write a function like this, it can be used by any user which has access to the database, and there is nothing that checks whose invoice this is. And we come back to the three questions here. There is no way we can actually find out who did this, and it will cost you a lot of headaches down the road in production if you don't take into consideration that inside of these functions and stuff like this, you should always find a way to basically just have a check which will prevent anyone from not doing this. Okay. A better authorization is basically this here. It's a simple fix. You just tie in the organization ID and the session of the actual organization. So if the actual invoice is tied to an organization, only those with roles tied to that organization will be able to find it and fetch it. So authorization at the query boundary is something, whoops, okay, sorry. It's a principle actually make illegal data difficult to query in the first place. And once you start to think of like this before you actually code, the request flows identify, then authorize, then check the context into a scoped query, and only then does it reach the actual resource. So putting authorization ahead inside of your queries and inside your actual mindset makes it really easy for you down the road to make good authorization systems and prevent the wipe coded ones and the ones which are not actually really functional. So let's say one code base, one deployment, many customers who must never see each other's data, call them organizations, workspaces, teams, accounts, companies. These labels actually don't matter. The isolation guarantee does. So the isolation of that actual workspace and the security clause that another person from another workspace or a team will never actually be able to query for data on your API from another ones. And that's basically the biggest point you can take away from today's session because, yeah, once you start thinking this way, it will become a lot easier and a lot more fun to integrate authentication into any actual backend. So the user is actually critically conceptual. It can belong to multiple organizations. So let's say a consultant working 3 clients across should be in organizations A, B, and C. So the user ID alone is never enough context to authorize anything tenant scope. You always have to have that check from a slide, from a few slides before, which would check his workspace, his organization, or something similar of his session. Because let's be real, sometimes we actually have multiple workspaces we work on, and we need to have multiple permissions on all 3 of them. In this case, we have something that comes to mind, and actually the term of membership. And it's think of it as a bridge table that connects the user to an organization via the role. It's a rarely glamorous, but the single most important table in a schema would be this. Every authorization check should eventually consult it. Is the actual user a member of that workspace or team or organization similar like that? Yeah. Okay, so what about context? So tenant context has to come from somewhere the request establishes a URL part, a subdomain, the current session in the selected workspace, or an API token scoped to that organization. It should never be taken from or inferred from something that the client can freely edit. So let's say his actual data. And in this case, if you take an example down below of via a URL part, that would be an app, which is a subdomain, example.com / the organization name / projects, which actually scopes down the permissions and roles to that server validated URL endpoint. Okay, and just because the client sent it doesn't mean it's true. So the client can send whatever tenant ID it wants in a body or header. That doesn't make it true. And this is basically where most teams fail and provide the most security issues, because the server must derive tenant context from something it controls. The authenticated session members' records, it does not have to include it, because if my server only can validate it and the context of it should come from a URL scope or a subdomain or something similar, that means that it can actually validate the context without the user having ability to spoof it. And that's how you prevent a lot of security issues today, and because with just a URL path. So let's say Alice crosses the line. So Alice belongs to organization A. The request a project inside organization B. Should the request succeed? Most likely not. Not until a bigger scope role authorizes it, and in this case, it would be the admin of the organization B. So you have in today's day and age 3 common models. So 3 common ways to store multi-tenant data would be a shared database, shared schema, one set of tables, every row tagged with organization ID, and then you have the shared database separate schemas. So the difference would be basically that it's a separate database, separate schema per tenant in case they differ, but they still need to share, like, let's say, a simple database. And you also have the separate database per tenant, which would mean that you have multiple databases in your project per actual tenants, depending on how big your actual project is and if your database can accommodate for all the different types of workspaces in your backend. Each trades isolation for operational simplicity differently, so there's no universally correct way to do this. It's basically just what's the most easy for you to do and what you think would be the best fit for your architecture of your backend. Okay. Yeah, shared schema. So let's say an example. In the shared schema model, every tenant-owned table carries an organization ID. That's basically how we fixed the query beforehand, and it's a boundary between customers sitting quietly in every table you'll ever write a query against. This is a really good approach for projects where you have a simple dashboard, but you have different users working on different lines for the same scopes. And every tenant-owned table needs a tenant boundary. So the only boundary you'll have is the organization ID to prevent anybody from actually making any dangerous queries in the behind the scenes, right? So if you take a look at these two queries side by side, one line of difference. The first returns a row ID alone, and it's without a boundary. So in case anybody would get access to your backend, they would simply get all your data without any fight back, and that would be a major security issue from the developer side. So the second one is the tenant boundary, and that one end clause is the entire difference between a SaaS product and a data breach. So this can make or break your actual SaaS project. There is a term, which is actually the very expensive where clause. So in SQL, if you forget it once and accidentally show Acme's invoices to the competitors, it becomes a major report title, and you'll most probably get into a lot of trouble from both of the companies. So forget it once and you'll build a cross-tenant data leak. And nobody actually wants data leaks, because showing another company's invoices to their direct competitor or a customer's PII to a stranger would be a major breach of security. This is how most in production breaches actually get written, just with one simple SQL word tag. So the biggest takeaway from today's session is, please, if you're gonna make anything resembling a SaaS or anything production related, don't forget this paradigm that this can be a really expensive thing to forget. And a lot of people ask, like, where should actually authorization live? On the front end, on the API route, on the actual service layer, on the repository, or the database? And the answer is basically all of them, but it's kind of a different approach. So the authorization lives inside of the database via the queries which we seen before. And in case it needs to be fetched from the database, that's where the repository layer comes in. This is basically the layer of your backend which communicates with the database, and it should be the single source of truth from where it comes through. And then from the repository, it should go to the service, to the API route, and only then back to the front end. So to answer somebody's question actually on YouTube, so if an authentication feeds into tenant scoping, what happens when a user belongs to multiple tenants? Does the token decide the tenants, or does the request? In most cases, if you follow along this principle, it will be decided by the actual server of you, but the actual way it will be decided is by the token that was actually minted and the organization ID flag which was set into it. So if you want to have the authorization live in every layer, and you should, how do you avoid it becoming inconsistent where one layer allows anything via single separation of concern? So the database should only talk ever to the repository, and it goes kind of like a flow. So to avoid anything mismatching, you have to kind of think of the flow as an actual role-based access control pattern, right? The database only ever talks to the repository, and the repository talks to the database, but is also responding data from it into the service. The service layer is the layer where it fetches it, so it doesn't fetch it from the database per se, but from the repository only. And in the service layer, that's where it gets mutated, it gets different operations done, anything you need to do with it, and only then does it send it to the API route. Once all of these are separated, it can only go into the front end from the API route, which actually has behind it layers like onions, but they all talk to a single source of truth. And how I saw that AI is affecting traditional authentication systems quite badly, because most people, when they start a project, they just open up Claude Code and they go like, hey, Claude, make me an authentication system. And most of these things, which are really important, will get most likely missed by Claude. And if you want a feature, and if I had to scope out the only feature which AI shouldn't fully write at this point of your backend is the authorization level, because it's the turning stone of your entire backend. If think of it this way, if that gets breached, everything, your entire backend is at cost of a data breach. So front-end authorization actually is just user experience. The front end should never, like said before, do anything authorization-wise, actually. The front end can hide a button, and only the backend can enforce a permission. And why do we do this? We do this as a security control that nobody can go ahead and open up your front end, go into the console of your browser and expose all of your functions and write a single return function which will scope out your entire flow. So the front end part, which is the last of the pattern, like besides the API route, should only ever have static buttons and requests sent to the API. So no authorization ever. And I don't know how much time it could save you or anything. Don't ever try to do it on the front end, because most likely you'll regret it in the future. So, centralized authorization. Instead of scattering if checks through route handlers, so imagine your code base and you're probably thinking, okay, now I need to go to each of my route and set conditionals. If user is admin, do this, else do that. Instead of that, we can centralize the decision behind one function, and that function would be authorized, and it would have some props inside of it, which would be, in my case, how I actually always do it, actor action resource tenant, and it should only return allow or deny. Every code path calls the same function, so the policy lives in one place and gets tested from one place only once. This way you avoid all the tangling of your backend to different if-elses, and in case something ever changes, this prevents you from actually having to go through 10 files and making a change in all the 10 files, but just making it here. Okay. We have a term also which we should go across is policy-based authorization. So this thing is a step further, expressing policies declaratively. So let's say you have two functions, can and authorize, which we went beforehand. Can is the function where you define if the user or the role can actually do a scope. And once you have enough resources, types, and roles, a policy engine like CASBO, also CASL, or like a more modern way of handling it would be clerk can pay by itself, because for most apps, a hand roll function is fine, totally, and you don't need all the complexity of having an entire SDK or an entire additional third-party service handling the single most important part of your backend, and that's obviously the authorization. Mostly when I see what people are saying, they go like, they're logged in, so it's fine. And authentication only protection is the most post-incidentally reviewed. They just logged in. Authentication can only protect authenticated users, regardless of the role or tenant. So everybody gets identical access but different roles. And in case that the being logged in is the floor, not the actual ceiling, right? So it's the base step of an authentication system. The front end hides the button, so a hidden button stops a confused user, not a curious one, with DevTools open and the terminal and curl. So we go back to the part where if you expose anything on the front end, somebody will notice and somebody will take advantage of that and cause you major headaches and most probably a data leak. So be very careful around that. One thing which a lot of teams in the postmortem say is that we pass tenant ID in the requests, and this can get especially dangerous because you can actually spoof the tenant this way. If the client name its own tenant and server believes, cross-tenant access is one edited request away. So I could basically just take the payload, edit it, and just return to the server, and it will most probably pass because the server only checks the tenant ID. Anything that the client can set, the client can lie about too. So you have to take into consideration that if I can set an actual tenant name and get the ID, I can also lie about who I am and get access to your admin system that way. So a lot of consideration goes also into this part of how do we prevent this happening, so spoofing happening. And another thing which a lot of people fail in is that admins can do everything. So the role explosion payoff, overprivileged admin accounts are the reason a single compromised credential becomes a full breach. In case your admins have all the accesses, think of it this way. You have all the power on your dashboard. And in case that gets breached, you have a contained issue and a real world incident where you will have to explain to everybody how somebody gained access to a system and had access to everything. So admin roles should mean admin of specific things, basically. And you can scope that out based on your business idea and what actually needs to be done by who. So don't it's a really bad practice to have super admins in your app, because if somebody gets access to those roles, they have all the power they need to go into your entire system and check everything out. Okay, and the most common, and I'm also accused of this, and I also done this a few times, is that we as developers say we checked authorization once. So we finished the entire system, it works, and we only smoke tested it once. Why? Because it takes a lot of time to test, to create test users, everything, to test all the roles, all the scope. It can get quite agitating. So this is the one failure mode where a lot of developers will fail, and it's basically just tail context. Long-lived workflows, a multi-step wizard, a background job, a cached session can outlive the extra permissions that Grant started with them. So think of it this way: if you didn't properly handle the logout, the session might still live in the browser, and the next user who logs in as a normal user might also have all the permissions from a logged in beforehand admin user. So a user demoted mid-session shouldn't keep acting on the old grant. So in case a user is logged out, muted, temporarily banned, or something, you should always first-hand check that all the grant scopes are handled, and anybody else logging into that browser will not have any of the grants which the previous user has. And authorization as general is a per action check, so not a per login check. You don't do this on the login side, and if you do, you'll end up with exactly this issue. It should be checked um, on a action check. So let's say if I can click this button, it would only check once I try. And obviously, if I'm not permitted to, it should be handled by the front end and be disabled. But it should not be post-processed all at once at the login screen. You'll have a lot of issues that way. One more thing I always hear is it's just an internal API. Nobody external will use it. It's just for us. So internal services get compromised, misconfigured, and called by things nobody remembers writing. Internal is a network location, so tied to your company or tied to your actual client, not at trust level, and you should never have the principle of thought, okay, it's just an internal thing, I can actually go away from some stuff just to make it a bit easier on myself, because trust me, it will come back and bite you in the near future, most definitely. So, how to defend from malicious cybersecurity attacks, and also how to make your actual authorization system completely robust. So the browser goes to the API, which pings the authorization, which pings the service, which in turn pings the repository, which pings the database. This sounds quite complicated coming to this, but think of it this way. This is all for security reasons, so that nothing can be compromised from the browser side. So if the browser communicates to the API only then communicates with authorization, which has its own service on your backend, and it's not visible to the API, right? So it can't be spoofed. It's only the wrapper is visible, and the service actually handles all the logic, which then pings the repository to handle all the logic in the database. So this approach I've used for years, and I'm pretty sure that you can't really go wrong with having this kind of scoping inside of your app, because mostly having this amount of separation of concerns that the only next level talks ever to itself and its nearest company. So authorization will talk to service, service will talk to repository, repository will talk to database. So you should make sure that the service never communicates directly to the database, but only via the repository. So could you give us a practical example of how authentication is handled at FlyRank? Exactly like this presentation. So authorization is a really big part of security, meaning that us at FlyRank really consolidate with it, and it actually goes exactly this flow, just in a different tech stack and in a different architectural perception. So yeah, the magic link stuff, it goes, actually that's the passwordless authentication flow, which actually communicates only via the email with the browser. And you have the exact same flow then raging forward it. Browser, API, authorization, service, repository, database. So one thing that I'm always annoyed at and is role level security. The database enforces mostly the boundary by itself. Even a buggy query can return another 10 rows. So this is something that if you ever use Supabase or Neon or some other backend as a SaaS product, which has their database kind of flow, this will come integrated, and it's a powerful defense in depth, and it basically just enforces the connection can only see rows belonging to its tenant. So from the database side, it's already enforcing rows, regardless of what application code does or forgets to do. This is especially useful in case that you forget the authorize function from before or the can function. Having row-level security enabled inside of your Postgres database will make sure that this will not happen on the database side. So it's one of the most powerful defenses, but me personally, I have a tendency to forget to enable it, so I get my pull requests denied and then I have to go back. So keep in mind that this is going to help you in the long run and that you always have to think of it, or not even yourself, assume that someone will eventually forget a check. And this will happen, especially in bigger teams in production. Somebody will forget that organization ID query, somebody will forget to enforce boundaries, and that's the entire argument for having defensive approach to designing this, and also real role level security enabled. So not that developers are careless, just that at scale across enough endpoints and enough years, someone will probably forget or your AI agent will. So just have that in the back of your mind that it will happen, and the biggest way to prevent a burning container of security issues and data leaks is having this defensive approach to authorization, basically making it bulletproof. So let's break it. So this is a deliberately vulnerable endpoint, and it fetches an ID with no ownership check. We're gonna attack it, and conceptually attacking this would basically mean just intercepting the payload, changing it, and transitioning back the SQL query the same way. So let's do the actual scenario. Alice from organization A, project 123 belongs to organization B, and Alice requests the get to projects 123. Should this return 200? Definitely no. In case this returns 200, you have done something wrong, and pull it out of production as soon as possible, because this will cause a lot of issues down the road, which I'm sure you don't want to be a part of. So to fix it, actually, like beforehand, just tie an organization ID or the session of the organization ID to the actual query. And this is in the actual repository handled, where your ORM handles communication with the database. And it's a simple fix. If you can, fix it. If you have to, if not, you probably already thought of it and implemented it the right way from the start. So the authorization checklist, something you would always have to check. Who is the actor? Are they a member? Which tenant context are they in? Does the resource belong to that tenant? Are they allowed to perform the action? And is the operation auditable? So these 7 questions will basically help you to decide when testing if your authorization workflow is robust or it needs work. If you can answer all of these 7 questions, especially the 7th one, and auditable means if you can review it and if an admin has an overview of it. Would that be a pseudo mode or an impersonation mode or logging mode? Just make sure that you can always audit what happens on the row level side of your application. And one rule of thumb, please default deny. If you haven't explicitly established that an action is allowed, it isn't. So, if you make a new feature in your app, deploy it, and you're adding it to the authorization flow, the role-based flow, if you haven't established it as an action in your head while architecturing it, it most probably shouldn't be allowed to be handled by all the users, so deny by default. Treat it as denied. Default allow is how one missing check becomes a breach, and default deny turns the same missing check into a support ticket. So this default deny will actually be the best practice you'll have in your workflow. and it's really easy to remember since it's only 2 words and is deny. So let's go over a simple authorization flow. So you have a request, you have the authentication, you have the identify actor, the resolve the tenant, and the check of membership. This is a whole design of a system in one diagram, and it's kind of more under the hood approach of how it would work and why it's important to distinguish authentication and authorization. So request only ever talks to authentication, which means the cookie side of the user. Is it expired? Does it have it? Some metadata, which in turn can communicate only with the identify actors. So basically the identification service. Does it belong to your server? Is it in your database? So this is the small backend part of your authorization on the backend. And that actor should resolve the tenant. So go to the repository, go to the database, find him, and check the membership. So if I request something from organization B, it checks my membership to that organization B. In case I'm not, it will not allow me that action. And once I check the permission, the scope research query will allow me the action. And really useful to have our audit logs just so you can see for yourself what's actually happening in the entire system. Okay, and rules to live by when making an authentication and authorization system. So, never trust the client, browsers, or actually any me, never trust me, just verify me. And user IDs are not permissions. Please don't make the mistake of making everything ID based because you'll regret it a lot in the future. So scope queries by tenant. One tenant, one scope. If the query has the scope in it, he can use it. If not, the query cannot be executed at all because it's missing the scope. So centralized policies use database level defenses, so row level security and stuff like that. Log sensitive authorization decisions, just so you have an overview for yourself. And authentication is not authorization. Authentication is just the floor, and authorization is the entire room. Tenant IDs from clients are untrusted. This, by default, needs to be the same as never trusting anything because before you verify it, it cannot be spoofed if you verify it on the server side. Prefer deny, always. Keep authorization close to the resource. So if possible, the authorization service, the authorization repository, the database. And minimize privileges. More privileges equal a more big data breach and a bigger headache in case that happens. Okay, how to test authorization? User A, he's a tenant, so we can allow him. If the tenant B tries and it doesn't have the tenant, we deny it. If a viewer has a read permission, we allow it. But if a viewer has a delete permission, we deny it because a viewer should always be read-only. And if an admin A is a tenant B, we should deny it. Even if you guys are admins in one workspace, if you try to be a single tenant in the workspace B, deny it. Because this is like the authorization matrix, which will turn your test suite just abnormally fast, and it will save a lot of time and effort to test this. So the actual authorization matrix is the table. These ones are the defaults for all role-based access control systems, and it's basically, if you're the owner, you own the workspace, you own the project, you have the delete actions, and you allow all of this. If you're an editor, you own the edit rules for the project, and we allow those. If you're a viewer, we don't allow deletes, but we only allow reads. And if you're an admin, of course, you have the delete permissions. So if the user is not an admin and he tries to delete, or an owner, let's say an editor tries to delete it, we should always deny it. And that's how actually the authorization matrix becomes quite useful in your mind, because, okay, an editor can never delete, remove the scope totally. And the closing. So we walked the entire chain from the browser to the API request to the authentication to the cookies to the authorization service, identity improvement, tenancy, scopes, repositories, handling of role level security in the database. Now, to return to the progression one more time. Everything of an authorization flow is basically just this. It's who, what, on what, in which tenant, under which policy. So who, an admin, what deletes a project, on what, on the workspace, on which tenant, on workspace A, under which policy, admin delete. In case a viewer would try this, it would fail because the policy would not be there, or the scope. So it's a simple rule of thumb, and it's quite an easy pyramid to have always in your mind when designing these kinds of multi-tenancy authorization flows. So, as the actual title of my today's discussion is, your application has trust boundaries and trust issues. Good architecture makes boundaries explicit. So like in a good relationship, boundaries make all of the magic flow. So that principle applies also to programming, and in case you go the deny always route and the boundaries, you'll have no problems with your applications, and most certainly you'll end up with less headaches down the road, and definitely less security issues. So if I would leave you with something from today's session, is you should always be, as a developer in general, able to answer in these questions. So how do we authenticate users? How do we validate membership? How do we scope database queries? Remember that and where clause, which can get quite expensive if you forget it. What happens if the client lies? Deny. How do we test cross-tenant isolation? Most commonly via impersonation or logs. How do we establish tenant context? via the browser. And how do we determine permissions? Single scoped from the database, always tied to the actual role. So the actual flow behind it. And where is authorization enforced? Never near exposure. So only on the server side and tied to the authentication. So authorization should never be visible to the end user to prevent major breakages and major data breaches. And what happens if a developer forgets to check if you have role level security enabled inside of your database? That would most commonly be no problem, right? Okay, and yeah. So leaving you with just a second. Ta-ta. So authenticated is not authorized, is not allowed to touch this tenant's data. So if a user is authenticated, it doesn't mean that he's authorized, and that's basically the entire difference. And the basically easiest way to explain to somebody why authentication and authorization are not the same, and why one without the another would either cause a major data breach and a major panic, and why only one would not work because it's server based. So it doesn't one doesn't communicate with the browser at all. And authenticated users are never allowed to touch tenants' data. Only authorized ones are with the correct scopes. So yeah, that's pretty much authenticated does not imply authorized. Authorized does not imply allowed to touch, and each arrow is a decision your code has made on purpose. So, in case you guys have any questions for me or anything that was missed, I'm here to answer them. So, I'm opening up the floor. Nobody? Okay. So, in case nobody has any questions, we can go ahead and finish this session. Thank you so much for listening to me, and hopefully we'll have the chance to work alongside the one each another in the future. So I did see one question which is what are some of examples where OAuth2 authorization server is important to implement? Yeah, in case you want social integrations mostly, most social integrations like login with Google, sign in with Apple, and we use the OAuth2 method because it's much easier to integrate into multiple projects. And yeah, a good example of that would be login with Google or login with Meta, login with anything, but doing a custom or tool workflow. The biggest example for that would be if you're extending your web application into, let's say, the mobile realm, and you need the shared authorization flow. yeah, I think that pretty much summarizes it. So a good example, worldwide Google, a good example when you're supposed to integrate it when moving to other platforms while having the same shared authorization flow. And yeah, what's the one mistake you see most often that looks fine on the surface but breaks everything in production? Um, Thinking too much of how to design it. Most people really over-engineer themselves when doing it, including myself. I'm also tight with. In the end, in the end, you should just do it. And if you follow all the examples I shared and the basic Urbach principle, you should make no, you should have no fears of it making any breakages, outages, or something like that. Also, one thing I see quite oftenly with authorization systems, especially huge custom ones, is that in due times when all the people change, developers change, code changes, people tend to forget to add scopes, add checks, add roles, and simply like that. Yeah, for implementing your own authorization server, depends on what framework you're using, what language, but let's do it polymorphically. I say don't have an OAuth2 system in place until you have the necessity to move off just web. And in case you're doing that, um, you can always use, especially if in Node.js and Dino, you can always use SDKs and packages which help you with the entire OKCE pattern, which is basically how the PKCE token gets authenticated from an OAuth perspective. But yeah, you basically just set up a response on your server tied to authentication, not authorization, expose the route, and allow any third-party client to have callbacks to your exact endpoints from theirs. So this might get discussed on another session because it's quite a big topic, but in the quietest piece of sense is just making sure that your token is validated either by a bearer or by a PKCE. And if you don't want to set up cookies while authorizing properly, JVT tokens are vulnerable to CSRFs. Yeah. Yeah, definitely. You can entirely leave authentication to Supabase, but keep in mind that if you want authorization in Supabase, you'll have to do some um, work of your own to make it work. And yeah. I think I answered all questions. If I didn't, please ping me. And yeah, if that's it, we'll go off in a minute. Yep, as mentioned, thank you so much. If you have any questions, feel free to ask all the Flyring staff, and looking forward to actually working with you on some of these things on this internship. And just remember, authenticated is not always authorized, and just keep in mind that these are two separate things but can't exist without one another. Thank you so much and enjoy the rest of your day.